Equations of tangents and normals. Let's consider this red point on our graph. Let's say that the point is at x equals to 1 and y is equal to 1. Okay, so that's where it is located. If the point is a point of tangency, as in a point that we want to know the tangent of, okay, and the tangent being a line that passes a curve and touches it only once, then the gradient of the tangent, so the gradient of this line, can be found by obtaining the derivative of the function, which in this case, this is the function f of x, so its derivative is f dashed of x. Okay, we can derive that function, and then we can let x equal to x1. So we can substitute x1 into the derivative function to determine what the gradient of that tangent line is. So we'll be substituting in x1 into that function, and that's stated here. We're simply just doing that. Okay. Let's take this further. Now, you can see we've discussed the word tangent, and we know that there's a point on this line. It's called the point of tangency. There's the word normal that appears here. What is that all about? Well, the normal is perpendicular to the tangent. So as we can see in the dot point, the gradient of the tangent times the gradient of the normal is equal to -1. You should be familiar with that formula, and you can transpose that to look like this if you like. Okay, so the gradient of the normal is perpendicular to the gradient of the tangent, and therefore we can use the understanding that if we multiply the two gradients together, they should equal to -1. Y minus y1 equals to m gradient of the tangent, x minus x1. This is a formula that you can use, and this will generate the equation of the tangent. Or you can use y equals mx plus c if you prefer, and then substitute in a point to find c. Okay, so these are two options to work out what the equation of the tangent is. And if you want to work out the equation of the normal, well, you can use this setup, and that'll spit out the equation of the normal straight away. Or you could do y equals to mx plus c, and then substitute in x1, y1 into it to find c, and then you'll know what your equation is. So you've got two alternatives there for each, finding the equation of the tangent and finding the equation of the normal. Let's have a look at an example now. Example, find the equation of the tangent and the normal to the curve with equation y is equal to 2x to the power of 3 plus 1 at the point where x equals to 1. Alright, it says to sketch a graph showing the curve and the lines you have found. Okay, so the first thing we need to do is we need to understand what this equation looks like. So y is equal to 2x to the power of 3 plus 1. So let's just write the equation down. So if x is equal to 1, and this is the point of interest where x equals to 1, let's substitute x equals to 1 into the equation. And we'll see that we get 2 plus 1, which is 3. Alright, now we know then that when x equals to 1, y is equal to 3 is a coordinate on that graph. So let's mark it on our axis over there. Let's mark that in. Now what else do we know about this? It's a cubic, and it's a point of inflection with a vertical shift of 1. It's dilated, so it's quite steep when compared to x cubed. So it's a vertical shift of 1 unit up. So that's here, and it's quite steep. It must go through that point, and because of symmetry, it'll go through this point here, and down like so. Okay, so there is our cubic, and we know that this point is on the cubic, and I'll write that down here, 1, 3. This is the point of interest for the problem. Okay, so when we're asked to find the equation of the tangent at the point where x equals to 1, well, that's asking us to find this. When it says to find the equation of the normal, it's asking us to find something that looks like this, the purple line. So we need to find the equation of the red line, the tangent line, and the normal line, the purple line. Alright, so in order to do that, we must know what the gradient of the tangent is at this point. And in order to find the gradient of the tangent at this point, we must derive the equation and let x is equal to 1. So let's do that now. So dy dx equals to 3 times 2, because we times down, and we drop the power to 2, and the 1 disappears, so that's 6x squared. So this is the derivative function. Now we want to know what the gradient is when x equals to 1. So we let x equal to 1, so that the gradient at that point is 6 times 1 squared, which is 6. So the gradient at that point is 6. So this means that the gradient of this tangent line is 6. Now, us knowing that the gradient of the tangent times the gradient of the normal equals to minus 1 would mean that the gradient of the normal is equal to minus 1 divided by the gradient of the tangent. So it's the negative reciprocal. So if this is 6, then this one is minus 1 on 6. Alright, so let's create our equations now. Well, we know y is equal to mx plus c. Y is equal to the gradient of the tangent, which is 6x plus c. And we know this point here can be substituted in for x and y because that point exists on the red tangent line. So 3 is equal to 6 times 1 plus c, and we get c is equal to 3 minus the 6, which is minus 3. So the equation of the tangent is y is equal to 6x minus 3. Alright, what about the equation of the normal? Same deal, y is equal to mx plus c. Y is going to equal to, now we know the gradient we said was minus 1 on 6, x plus c. Now we're going to have to substitute 1 and 3 into that, so 3 is equal to minus 1 on 6 times 1 plus c, and c is equal to, well, you take the minus 1 on 6 over to the other side and you get 3 plus 1 on 6, which is 3 and 1 on 6. So the equation for the normal is y is equal to negative x on 6, or negative 1 on 6, whichever you like, and then plus 3 and 1 on 6. Now, typically, we can represent it as y equals mx plus c if we like there, or we can represent without the fractions. So we multiply everything by 6. So that'd be a 6y is equal to minus x, and the 3 and 1 on 6, well, that's 6, 12, 18, 19 on 6, which is plus 19. And then we just rearrange, so x plus the 6y equals to 19. That's a more elegant way to represent the answer. All right, so we have our two equations and we can label them if we like on the graph. So this is x plus 6y equals to 19, and this is y equals 6x minus 3. And if we're sketching it properly, then we should see, well, let's maybe adjust our lines here. So let's start with the equation of the tangent. We see that the equation of the tangent crosses at minus 3, and minus 3 is down here. So we need that line to cross there, and that would be the appropriate gradient if it's touching that point and crossing at minus 3. And for our equation of our normal, we can see that we cross at 3 and 1 on 6. So that's approximately 3 and 1 on 6. I'm pretty happy just to leave my line where it is there. Okay, so there we have it, and we may want to write in that value, 3 and 1 on 6. But there we have our sketch. There we have our equation of the tangent, and over here we have our equation of the normal in two different formats.